Number 895, ASEAN transportation, electrification to reduce oil imports. Transportation observed historical data shows that the TFEC of ASEAN transportation grew dramatically from 74.2 megaton in 25 to 133 megaton in 2020, with an AAGR of 4.4%. Specific share contributions were road 93%, domestic air 3%, inland waterways 2%, rail 0.5%, and non-specified sector 0.1% in 2020. In the baseline scenario, average annual consumption is forecast to increase approximately 12 megaton over 2021-2050. The projected TFEC in transportation will reach roughly 220 megaton in 2030 and 332 megaton in 2040 and 492 megaton in 2050. Oil is the primary fuel source, accounting for 91% of the TFEC in the transportation sector in 2020, followed by biofuels 7%, natural gas 1%, and electricity 0.2%, very small. Also, the oil share was the largest every year. The AAGR of oil is only 3.5% per year, the lowest fuel consumption growth rate from 25 to 2020. But biofuel consumption increased the fastest, with an average annual rate of 51% during the same period. The average annual rate for natural gas and electricity consumption growth in the transportation sector was 20% and 7%, respectively, during 2005, 2020 to 2020. And based on historical trends, oil will contribute a 91% share of ASEAN TFEC in the transportation sector by 2050, followed by biofuel 7%, natural gas 1%, and electricity 0.2%. Biofuel consumption will grow the fastest over the 2021-2050 period, with an average annual rate of 4.7%, followed by oil consumption at 4.4% per year. Natural gas and electricity consumption for the ASEAN transportation sector are forecasted to increase an AAGR of 3.8% and 3.6%, respectively, during the same period. And to reach the national targets in ATS by 2025, oil and gas consumptions needs to be decreased by 18 and 1%. Respectively, as compared to the baseline scenario. On the other hand, electricity uptake must be greatly accelerated to 388% higher than the baseline scenario, followed by biofuel 11%. In order to realize the regional targets by 2025, under APS, a further decrease in fossil fuel must be achieved. Oil consumption in transportation is much lower in ATS and APS. In 2050, ATS shows reduced oil demand in transportation by 59% to 112 megaton, with an additional reduction of 33% in the APS as compared to the baseline scenario. Establishing policies in the transportation sector in member states is crucial for attaining the APEC targets. In the APS, in which EVs are favored biofuels mandates, and fuel economy improvement strategies are set and or enhanced to meet the regional target, with significant fuel saving potential expected. Deploying more efficient electric and hydro vehicles in parallel reduces gasoline and diesel usage by about 72 and 59% on average. Respectively, this entails less dependence on imported fuel, but more importantly, enhances urban health and welfare due to less air pollution from fossil fuel combustion. Transportation consumption by fuel across scenarios, and oil is very big, most large factor. Yeah. Fuel shifting in road transportation, APS versus baseline scenario. And gasoline is gray, and diesel is orange. Road vehicles account for most of the energy consumption in transportation, with targeted annual growth averaging 10.8 megaton, reaching 91% of TFEC in 2050. Meanwhile, the other modes of transportation are not projected to grow significantly, with a respective annual average over 2021-2050 of 0.86 megaton, 0.27 megaton, 0.05 megaton, and 0.01 megaton for domestic air, waterways, rail, and non-specified, respectively, over 2021-2050. Amongst road transportation, private passengers vehicles will have the dominant share with 50%, followed by trucks and other at 32%. AMS provide promising targets and strategies for increasing the technology uptake. However, despite establishing these policies, conventional vehicles still dominate the passenger road transportation fleet in 2050. In the ATS estimation, EVs only reached up to 2.5% of the fleet by 2025 and up to 9.6% by 2050. Higher EV targets and/or establishment of transportation electrification policies are needed to yield more energy saving in the sector. TFEC projection by road transportation baseline scenario. Gray is a motorcycle, and blue is a road private passenger vehicles. It's a very high share. Penetration of electric vehicle in road transportation, ATS, motorcycle, in the conventional is very, very big share yet. Flexibility options in the transportation sector. As one of the largest electricity consumers, the transportation sector can contribute to increased power system flexibility, and its role can be further enhanced through sector coupling strategies such as EVs. AMS have shown great interest in EVs and set specific development targets. EV development is expected to increase overall electricity demand, especially during over hours when drivers charge their vehicles. Coupling with VRE means major change in energy supply and demand profiles can be expected. This will require a new definition for peak and off-peak energy demand. EVs have been shown to provide grid management solutions, such as peak curtailment and VRE balance, but they require active participation from user side. Without proper smart grid system for energy management, accommodating the increasing quantity of EVs would challenge the current grid. Hence, holistic strategic integration planning that encompasses technical, economical, and social sensitivities is required to ensure a successful transition of the transformation sector. For conventional internal combustion engine vehicle, ICEV to EV. EV technology has advanced to solve many past problems, such as slow charging and EV mileage. Currently, fast charging can reach 10,800 watt-hour to 21,600 watt-hour, and typical EV mileage can achieve 600 kilometers with a fully charged battery. However, charging station coverage is still lacking. As of September 2021, Singapore has the highest number of charging stations with 1,800 public charging points. Thailand has 1,000 charging stations, Malaysia 600, and Indonesia has 187. Based on European Union EU recommendations, one charge station is required for every 10 EVs. The total well-to-wheel WTW efficiency for ICEVs running on gasoline range from 11% to 27%. Integration of EVs, assuming the grid is powered by coal-fired power plants, will result in similar WTW efficiency of 13% to 27%. Though EV use is slightly more efficient than conventional vehicles per kilometer basis, relying on conventional power plants for electricity is inefficient and unsustainable. A low-carbon solution for grid power using renewable energy is important to increase the efficiency of EVs, especially when renewable energy supplements the distribution network. It is in line with ASEAN's direction toward higher development of RE across the region. Fueling EVs with RE resources can increase the efficiency of EVs from 40% to 70%. The concept of vehicle-to-grid V2G is of major importance to drive behavior toward optimal EV charging. With V2G, users can sell power back to the grid from their EV energy storage system during peak hours. Another added benefit is that in an integrated grid system with VRE, EV storage can also store surplus energy, thus allowing for better balance of supply and demand. It leads to improved efficiency in power grid operations. V2G technology faces several challenges, including battery deregulation, high implementation costs, and connectivity. Recurring charging and discharge cycles can damage batteries and pose a significant obstacle to using lithium-ion battery in EVs. The high implementation cost of V2G is primarily due to the hardware and software infrastructure required and needs to be improved. A high-tension cable, a complicated controller, and a bi-directional charger, and required for every EV to access V2G. Bi-directional charging allow charging and discharging energy from an EV battery. Compared to conventional EV chargers using alternating current AC, the bi-directional chargers act like an inverter to convert AC to direct current DC. They are only compatible with EVs that allow bi-directional DC charging. At this time, EV remains more expensive among ASEAN countries, especially where transportation fuel costs are subsidies, such as Brunei Darussalam, Indonesia, and Malaysia. EVs are still less economical than conventional vehicles. However, as expected, EV costs will decline as cheaper batteries are developed. So, VTG may allow users to gain some revenue from selling electricity back to the grid. So far, no functioning models for VTG financial mechanisms have been implemented in ASEAN, not only for flexibility in the industrial sector, but TOU tariffs could also be implemented in VTG. The transition from conventional transformation to EVs will not occur overnight, but expectations are for gradual growth over the next few decades.